Okay, in this video we are going to see Introduction to Binary Search Sorting by diminishing increment and finally sorting by partitioning. Okay, let's start with binary search. Here's an introduction to binary search. What is binary search? Binary search is an efficient algorithm for finding an item from a sorted list of items. It works by repeatedly dividing the list in half until the desired item is found. Method 1. Start with a sorted list. 2. Find the middle element. 3. Compare the target element with the middle element. 4. If the target element is less than the middle element, repeat steps 2 to 4 with the left half. 5. If the target element is greater than the middle element, repeat steps 2 through 4 with the right half. 6. Repeat until the target element is found, or the list is exhausted. Example. Suppose we have the following sorted list: 1, 3, 5, 7, 9, 11, 13, 15. Target element, 9. Step-by-step search, 1. Middle element, 7, 2.9, greater than 7. Search right half, 9, 11, 13, 15 third. Middle element, 11 fourth, 9 less than 11. Search left half, 9 5. Found, 9. Algorithm 0 binary search RR target. Here R is array, so binary search, array target, low, 0 high, R's array dot length, 1, while low, R's high, mid, R's low plus high. 2, if array mid, R's target, return mid elif array mid, target, low, R's mid plus R's 1 else, high, R's mid, 1 return -1 / not found. This is the algorithm of binary search. Program, C program. Here's a simple binary search program in C. Include int binary search, int R, int n, int target, int left, var 0, int right rn, 1, while left, right, int mid, rf, left plus, right, left, h2, if, array mid, var target, r return mid, else, if, array mid target, left, r's mid plus var 1, else, right, r's mid, 1, thar return, 1, target not found. Let's keep array element as 2, 5, 8, 12, 16, 23, 38, 56, 72, 91. So let's write a program on it. Then, into main, int array. 2, 5, 8, 12, 16, 23, 38, 56, 72, 91. 12, 16, 23, 38, 56, int n size of array. Size of array. Int target, 23, int result, odds binary. Search, array, n, target. If result, ja, odds, 1. Printf. Target 23 not found in the array. N, target. Else, printf. Target %d found at index %. N, target result. Return 0. Bar tracing. Here's a step-by-step tracking of the binary search program. Input, the key information needed for tracing. Array, 2, 5, 8, 12, 16, 23, 38, 56, 72, 91. Target, 23. Array size, 10, so let's keep it inside. In iteration 1, left equals 0, right equals 9, mid equals 4, calculated as 0 plus 9 divided by 2. 9. 2, r mid, equals 16, comparison, 16 less than 23, move left to mid plus 1 equals 5, so in iteration 2. Left equals 5, right equals 9, mid equals 7. Calculated as 5 plus 9 divided by 2, minus r at mid equals 38. Comparison. 38 greater than 23, move right to mid, 1 equals 6, let's see. Iteration 3. Left equals 5, right equals 6, mid equals 5. Calculated as 5 plus 6 divided by 2. 6 divided by 2 equals r at mid equals 23. Comparison. 23 equals 23, return mid equals 5. So finally, output, target 23 found at index 5. In tracking table, iteration, left, right, mid, r, mid, comparison, action, 1, 0, 9, 4, 16, 16, 23, left, 5, 2, 5, 9, 7, 38, 38, greater than 23, right equals 6, 3, 5, 6, 5, 23, 23, 23 equals 23, Return 5. This tracking demonstrates the step-by-step process of the binary search algorithm finding the target element 23 in the sorted array. Binary search has a time complexity of O log n, making it much faster than linear search ON for large datasets. Okay, that's it. Let's see an easy example how a binary search works. By taking 1 to 10 as array, and let's find where is 9. That's it, we found. I hope you would have understood. Thank you for your attention. Now let's see what is sorting by diminishing increment.
Sorting by diminishing increment, also known as shell sort, is an efficient sorting algorithm. Here's a comprehensive overview. What is shell sort? Shell sort is a comparison-based sorting algorithm that generalizes sorting by exchange, bubble sort by allowing the comparison and exchange of far-apart elements. Method 1. Start with a large increment gap between elements. 2. Compare and swap elements that are increment apart. 3. Gradually decrease the increment gap and repeat step 2. 4. Continue until the increment is 1, essentially bubble sort. Example: suppose we have the following array: 5, 3, 8, 4, 2, shell sort with increment 3. Compare 5 and 2, swap since 2 less than 5. 2, 3, 8, 4, 5. Shell sort with increment 2. Compare 2 and 3, no swap. Compare 3 and 4, swap since 4 greater than 3. 2, 3, 4, 8, 5. Shell sort with increment 1, bubble sort. Compare 2 and 3, no swap. Compare 3 and 4, no swap. Compare 4 and 5, swap since 5 greater than 4. 2, 3, 4, 5, 8. Shell sort algorithm. Shell sort is a generalization of insertion sort, where we start by sorting elements that are far apart from each other, then gradually reduce the gap between elements to be sorted. It uses a gap sequence, commonly having the gap each time until it reaches 1, i.e., we perform an insertion sort shell sort steps. 1. Initialize a gap. Start with a gap of n/2, n2, where n is the number of elements in the array. 2. Gapped insertion sort. For each gap, sort the subarrays formed by elements separated by this gap. 3. Reduce gap. Continue having the gap until it becomes 1. 4. Insertion sort. When the gap is 1, the array undergoes a final insertion sort, resulting in a sorted array. #include less than stdio, h greater than. Function to perform shell sort. Void shell sort int arranged by int n. Start with a large gap, then reduce the gap. For int gap equals n2, gap greater than 0, gap equals 2. Perform a gapped insertion sort for this gap size. For int I equals gap, I less than n, I plus plus. Int temp equals arranged by I. Int j, shift earlier gap sorted elements up until the correct location for arranged by I is found. For j equals I, j greater than equals gap and an arranged by j, gap greater than temp, j equals gap. Arranged by j equals arranged by j, gap. Closing curly bracket, put temp the original arranged by I in its correct location. Arranged by j equals temp. Closing curly bracket, closing curly bracket, closing curly bracket. Function to print the array. Void print array int arranged by int size. For int I equals 0, I less than size, I plus plus. Print f%e, arranged by I. Closing curly bracket, print f n, closing curly bracket. Main function, int main, int arranged by equals 12, 34, 54, 2, 3. Int n equals size of arr 0. Print f original array, n. Print array arr, n. Shell sort arr, n. Print f sorted array, n. Print array arr, n. Return 0, original array, 1 2 3 4 5 4 2 3. Gap, 2, array after inserting 54 at index 2, 1 2 3 4 5 4 2 3. Array after inserting 2 at index 0, 2 3 4 5 4 1 2 3. Array after inserting 3 at index 1, 2 3 5 4 1 2 3 4. Gap, 1, array after inserting 3 at index 1, 2 3 5 4 1 2 3 4. Array after inserting 54 at index 2, 2 3 5 4 1 2 3 4. Array after inserting 12 at index 2, 2 3 1 2 5 4 3 4. Array after inserting 34 at index 3, 2 3 1 2 3 4 5 4. Sorted array, 2 3 1 2 3 4 5 4. Explanation of the trace. Gap, 2, when gap equals 2, elements at indices 0, 2, 4 form one subarray, and elements at indices 1, 3 form another. The program performs a gapped insertion sort on each subarray. It moves 2 to index 0, resulting in the partial sorted state 2, 34, 54, 12, 3. Then, it moves 3 to index 1, resulting in 2, 3, 54, 12, 34. Gap, 1. When gap equals 1, the program performs a standard insertion sort across the entire array. It places each element in its correct position relative to previous elements, resulting in 2, 3, 12, 34, 54.
Okay, now
After
let's
the
see how
final
sorting
pass,
by
the
diminishing
array
increment
is
actually works.
fully sorted.
Next, finally, we are going to see about sorting by partitioning.
Sorting by partitioning. Sorting by partitioning generally refers to quicksort, an efficient, comparison-based sorting algorithm that uses the divide and conquer strategy. Here's an explanation of the method, algorithm, example, and program tracing for quicksort. 1. Method. The quicksort algorithm works by dividing the array into partitions based on a pivot element. The process is as follows. Choose a pivot element from the array. There are different strategies for choosing the pivot, such as selecting the first element, the last element, or a random element. Partition the array around the pivot. Elements less than the pivot go to the left, and elements greater than the pivot go to the right. Recursively apply quicksort to the subarrays on the left and right of the pivot until the entire array is sorted. Here's an explanation of the quicksort algorithm using partitioning, along with AC program and tracing. Quicksort algorithm. 1. Choose a pivot element. 2. Partition the array around the pivot. 3. Recursively sort the subarrays. Partition scheme. 1. Select the last element as the pivot. 2. Initialize two pointers, I and j to the start of the array. 3. Iterate through the array. If j is less than the pivot, swap arr I and arr j increment I. Increment j. 4. Swap the pivot with arr I. 5. Return I as the pivot index. Asterisk C program. Hashtag include less than stdio, h greater than. Int partition int arranged by int low, int high. Int pivot equals arranged by high. Int I equals low 1. For int j equals low, j less than high, j++. If arranged by j less than pivot, I++. Int temp equals arranged by I. Arranged by I equals arranged by j. Arranged by j equals temp. Closing curly bracket. Closing curly bracket. Int temp equals arranged by I+1. Arranged by I+1 equals arranged by high. Arranged by high equals temp. Return I+1. Closing curly bracket. Void quicksort int arranged by int low, int high. If low less than high, int pivot equals partition arr, low, high. Quicksort arr, low, pivot 1. Quicksort arr, pivot +1, high. Closing curly bracket. Closing curly bracket. Void print array int arranged by int size. For int I equals 0, I less than size, I++. Printf %e, arranged by I. Closing curly bracket. Printf n, closing curly bracket. Int main, int arranged by equals 5, 2, 9, 1, 7, 3. Int size equals size of arr, 0. Printf original array. Print array arr, size. Quicksort arr, 0, size 1. Printf sorted array. Print array arr, size. Return 0. Closing curly bracket. Tracing. Original array. 5 2 9 1 7 3. Partition 1. Pivot. 3. I. 0. J. 0. Arranged by 2 1 5 9 7 3. Pivot index. 1. Quicksort 2 1 5 9 7 3 0 0. Partition 2, pivot 1 I minus 1 j 0, arranged by 1 2 5 9 7 3. Pivot index 0, quicksort 5 9 7 3 2 5. Partition 3, pivot 3 I 1 j 2, arranged by 3 5 7 9. Pivot index 2, quicksort 5 7 2 3. Partition 4, pivot 7 I 1 j 2, arranged by 5 7. Pivot index 2, sorted array 1 2 3 5 7 9. Here is the animated video for sorting by partition.
Do you know which sorting algorithm uses partition technique as well as divide and conquer strategy to sort the array? Consider a line of students. Teacher wants to sort the student according to their height, but teacher doesn't want to spend time on sorting each student individually. So teacher asks students to sort themselves. Now there are 5 students in a line: Ross, Rachel, Monica, Phoebe and Joey. So the student selected one person, consider Monica. So all the students which are taller than Monica will stand behind her. For example, Ross and Rachel are taller than Monica. Then they will stand behind her and rest of them will stand in front of Monica. Now Monica is in sorted position. So we have to perform the same operation on right side and left side of Monica. So again, student on the right side will select one person and sort themselves according to it. And the same thing will happen again on the left side. So person or element which is being selected for sorting is called as pivot, and we are partitioning our array according to that pivot element. This means we are dividing array and then sorting it, means we are using divide and conquer strategy. This type of sorting algorithm is called as quick sort, and 99% of the time complexity of quick sort is n log